decision, our first choice should be the first line. Then the cost of electricity. It could be in your local currency. Now I guess is in USA dollars per kilowatt for this technology. And then it goes up and up and up. This is the fraction of renewable systems, and this is the amount of diesel used per month or per year. It depends how you fix this, how you configure or set this information. How, let's say diesel. Why diesel? Because in this technology, this simulation decide to use diesel. It's not every single simulation. It depends if you has the resource and you have to use it maybe in some hopefully technologies. Okay, this is how to understand the results. Now I'm going to stop here to go to the systems. Let's say keep this, stop here. Sorry, I'm going to change to the real software over here. Okay. I hope everything is being understood. Sorry for any inconvenience about it. The sample, where's the sample? Okay, I'm going to show you this example. This is the software, the licensed software. I guess, I'm not sure, I guess it has most of the blocks and icons and the diagrams that you could see on your download software. The first part is the home place, and in that map we could wait it over here. We could decide what part of the world we are going to make the simulation or the optimization, and then using the scope be closer to the place. In this example, we were working on a place on a village, the Pacific coast. And in this model, first we're going to the resources. What do I need? Solar resources. So we go to the top at the right part where it says resources. There's a icon so you can make click here, and it says, okay, what do you need? I need the information of the NASA, the National Aeronautical System from the United States. If I need wind, because I know, yes, I know they have a lot of wind here, I use it, but not in this case. So I say, okay, download, and I click on it, and then it appears a diagram like this one, where here in this block diagram it shows us the daily radiation in kilowatt per hour per square meter per day. This is the way we usually take this input information in kilowatt hour per square meter per day, and it gives us average for every single month. This is 3.6 kilowatts, so 3067 watt hour per square meter, February, March, April, May, etc. And you have an annual average. Okay, how do I know if it's good or if it is bad? As you saw at the beginning, I show you Colombia. We are in the equatorial and tropical zone. We have a lot of sunny resource, sunny radiation. This is a very good average. Of course, 5 or 6 would be better. But in the Pacific coast, where I'm doing this and showing you this example, it has a lot of raining season. So, however, this data is showing us that has good average, 3.91. It's a good one. Okay, this is the main resource, and they also have fuel. And you can use here different diesel or let's say fossil fuels if you need it to have a good complement for solar system. In this case, we only decide to work with, we decide only to work with solar. So we download the solar resource and began to look for components in that part of the software. In the at the top, you see the different components, PV, and in the PV part, we click on it and it says generic flat plate concentrating technology that is for big big plants as 1 megawatt, but let's have in mind that it is a thermal power system, and it has some mistake like this. It is the name of the controller. I don't know why it is here, and this is a a solar PV model. I don't know what is here, but maybe you says I don't want to use this. I want to see, as Professor Yuri says, a complete catalog of solar modules with many manufacturers, and he says, and it is here, complete is so far different brands, different manufacturers. We can move and we can work with this table with. Pay attention to this because sometimes Homer has this mistake. For me, it's a mistake. I just click on complete catalog of solar systems or solar modules. I'm going to choose the solar system, the solar module, and suddenly, look, Fronius Galvo, those are inverters. So there is a mixture of inverters and solar PV systems. Kijo, I don't know what is it. Longier solar PV modules, good. Trina, SunPower, Studer are converters and inverters. I guess this is a converter, I'm not sure. SMA is a top brand, very used in Europe. Here in Latin America are expensive, but very good in solar PV inverters. Yes, Schneider's converters, inverters. So for this example, we use some of this solar PV system. You can see all the features and technical characteristics of every single technology. Okay, let's see the schematic to see what happened here. What have here. Uh, we decide in this example to use Jinko 265 watts per module. If I click on the schematic, it takes us directly to the characterization and in the way we work with the solar module. Then the batteries, I click on it, and it says, okay, you use for this example, kinetic battery model, 12 volts. This is the cost, the real cost of the real cost in Colombia. Pay attention to that this is a worldwide software. But if you are going to develop for real this system, try to find in your local uh, market, maybe in the full country, search in Bangladesh what brands, what manufacturers of solar PV systems are commercial. Not only because Homer says, oh, there's a brand, there's a manufacturer, let's say, car, car batteries. Yes, but car batteries only for USA. I can work with it in Colombia. I work with Trojan. I work with Victron, I work with, okay, several others. This is the bus bar, the DC bus bar, where we connect, as I told you before, the DC technology, that is the solar PV system, and the battery. And of course, the converter. I click on the converter, and it says the converter selected is Studer Extender 1200 in power. The, this is the manufacturer, and a web page to see or compare another. Maybe I like to have not this one, another one. Okay, I like to erase this one, so I go here, go to remove, and create a new one. But with this, I need the costs, the real cost. So I call or write an email or look for it on internet. And in our case, this converter costs about $387 for this capacity. This is not too much. This is maybe for a home, a regular home, 2, 3 people with their appliances, their electrical appliances, TV, fridge, uh, cleaner, and music, etc. And this is the cost of this one, just one converter. So I place it in this short matrix to optimize, or to create, sorry, to create this. I'm going to click on it twice. Let's see, sorry, here. Click here to add a new item. Why? Because maybe I like that HOMER identify or look for another solution, another possible solution. So I'm going to use another capacity. And he's going to create another simulation for this new student, for this new converter. How much it costs? Let's say, I don't know, 800. Inventing this. Here, the cost of replacement. Why? If it is new, yes, but what happened in few years, you need to replace. This cost should go into the budget of the system, into the entire budget. So I'm thinking that maybe a board, I don't know, the displays. So let's say that it costs just 180. What is this column? Output and maintenance. How much per year? Let's say 100. Okay, ready. What happened with this? HOMER has 2 ways to optimize this. One is he can optimize automatically with this information, or we can tell the HOMER that only search and create the iterations with this equipment, just 1.2, 2.4, 3.6, and maybe I'm going to tell it that there's another one, 5 kilowatt and 10 kilowatt. Okay, in this way, he will create an iteration for 10 kilowatt, 5 kilowatt, 3.6, 2.4, 1.2. And between them, he's going to give us the results to we decide. But the first line, as I showed you before, would be the optimize. Okay, then the load. This is what I told before about how to create this load profile. It gives us the chance to change these numbers in kilowatt. Take care with be careful with this. This is the power at 0 hour, 1 hour, 2 a.m., etc. And For this example, this is the low profile. Okay, let's say everything is ready. There's a suggestion here that it says model doesn't match results. Maybe because I moved and changed it, the original. But at the end, you can see here, the right side at the top, that this give us the option of to calculate and click on it. This is the result. Only 90 simulations, very fast. And he show us um, this figure and more other figures and graphs that we could research slowly in a few minutes. But give us this information: system architecture, these equipments. This is the way we are going to invest. Look at the beginning. The capital is a lot of money that we invest on it. But okay, it says 1,200 or 300. Okay, and it has the table what we need. And the table, only one result. What happened with the rest of the simulation and the iterations, okay, are here with overall. If I click on overall, it show all the simulations he created, and it says 90, I guess. It says before 90 simulations. Okay, between all them, it decide that this one, the first, in the first line, this one is the best choice. It's optimized, mixing technologies, prices, and the way that low energy demand works. They it going to use solar PV system, battery converter. The solar module is the Jinko manufacturer 265, only using less than a kilowatt. I guess two solar modules, I guess. This is the converter. No, sorry. This is the battery. Only one battery, 12 volts. This is the converter. This is the net present cost of the system. This is the cost of electricity that is cheap. The operating cost, dollars per year. The capital, and some other things. So this is just an example working on it. I would like to see if it is possible. I'm not sure. Some of you could share to me if you are making the simulation and resolve some questions if you have it.
Hello, I have a question, please.
Yes, of course.
I'm Dr. Fawad Azim from Pakistan. I just want to ask one question, that when you are designing for solar system, then how you are adding the cost of the solar? Could you please elaborate on that?
Okay, sorry. Your question is that how I decide the cost of the solar PV
Yes,
system?
exactly.
Okay, first, because I need to put into the software, the software needs some price. So the first thing you need to do is to research on your local market. You said that you're from Pakistan. Maybe look in all in Pakistan. What are the not the manufacturers, every single panel and all these technologies manufactured in China. Some of them, for example, the Adani solar PV models are in India and are moving very well, and is a very qualified system. But the rest of the technology from China. But look into your local market to see your prices. So you decide between real technologies with real prices and write and put all this information into the software. In that way, the software will give you real results that your
So,
system will cost in your currency. I didn't show how change your currency. Sorry, but this is the way. Did I answer what you asked?
So what I normally do at Homer is that we are going to, I personally add the cost of per kilowatt system. For example, the per kilowatt system cost is about 25 rupees in Pakistan. So I'm not going to add the overall cost, but I will be only adding 25 rupees per kilowatt for the solar cost. This is what you mean.
Yes, but you told me something about the electricity cost, right? And the electricity on grid to the electricity grid system. I just thought I just tell you about the simulation or in the during the first stage in the simulation and the let's say
No,
the design stage
yes, sir. I understand
where
your
you
point,
place
but
this. Okay.
if you could please go on to the design tab for just for on design tab. Uh,
Mhm.
or,
This is for the load,
no, design,
and I
design.
guess okay. In it shows the same
If you
on
could,
home, just
yes,
the
if you could,
map and design,
if if you could please click on the solar
just
side,
basic business.
solar, solar icon. Here you are
Yeah.
going to select
Okay,
one
this part.
from here. Yes, this one. I'm talking about this capacity point 265
Mhm.
per kilowatt. This is what we have
Okay.
taken.
Okay. Okay. So why 265 or 300 or 400 or
But this will be
400
for
watts? How
per
do I
kilowatt.
decide this? Mhm. Because okay, in this part we place. Let's another example here. We are going to write here the power of one solar module. Here in our region, right now we are using 400 watts solar modules. Are very common. It costs about $100 US dollars per per module. So I know that I can find easily this solar module. I'm going to use it. In this column, it says right here in kilowatts, my solar module is 400 watts. So I'm going to write 0.400 because this column is in kilowatt. Cost, oh my God, what happened? Cost, and it says that this column in costos, look at the Homer automatically place or put the rest of the costs. I'm going to change it. In this cost, this is the real cost, so I call a search or something like that. And this solar module costs about 100, let's say 100. Just this one, it is being cheap right now, so I'm going 200 US dollars, just one solar module. And replacement, if this is damaged, this solar module is damaged, I should replace the entire module. So the cost for this replacement is the same. It changed when I'm thinking on a converter or an inverter or something like that, because I certainly I won't change the entire converter or the entire inverter, only a part of it. So maybe the display or let's say the power board, something like that, or a transformer, something like that. So cost for replacement in converter or inverter would be less.
Okay.
After this,
I have one more question. If sorry to interrupt you. If I add
yes, it's
one
okay.
kilowatt, if I add 1 kilowatt instead of
Mhm.
0.265, and I
Okay.
say that it's 1 kilowatt and and the capital cost for 1 kilowatt is about maybe 1,000 rupees. I'll be talking in
Mhm,
rupees because the
mhm.
currency is Pakistani. So I'm
Yes,
not
you
going
have to
to.
multiply that one.
Yes. So what I'm going to do is I'm adding the capacity of 1 kilowatt, and
Mhm.
that 1 kilowatt is actually about 25 rupees as per Pakistani. So in this way, you are adding the capital cost of 25 rupees per kilowatt. Is this correct? What do you think?
Yes, yes, yes. It should be let's see, let's see, proportional, 23 or something like that. So you have need to uh, add more power. For example, I wrote here. I don't know if you are seeing this. This number are very small.
Yeah, I've zoomed it and I can easily see that it's written
Okay.
1.2
Yeah. Sorry, I
kilowatt,
can zoom
and
it more.
for 1.2 kilowatt, it's $600.
I just
Right.
multiplied. Yes, I just multiplied the cost for because in my example I have a solar module, a 400 watts solar module that costs 200. So three times this would be three times the cost of this. But replacement doesn't mean that goes three times. When are going to replace could be um, cheaper or something like that. Of course, there's another situation. Let's say, for example, 4 kilowatts. 4 kilowatts cost less than because of general commerce and market everything. So the cost for one is 200. Let's say that this could cost, let's say, for 10. So I'm going to write just 1,100, and cost will be, better for a big uh, system. It's just market and commerce. But uh, this is the way Homer create this cost curve. And after that, they say, okay, he's going to optimize considering those prices and uh, those new technologies or costs and solar models that we just brought. So the question here is to have really the the actual cost for every single technology that is commercial on your region or your country, and then multiply to make the entire table, and Homer will create this cost curve to the optimization. And then he's going to play and create a new iteration. Again, I'm going to calculate with this one the same, and results are exactly the same because he optimizes and says you can write and put many single solar modules, but this is the best uh, system suitable for the load profile that you give us, that is here in design. For this load, Homer says the best result is this one, categorize here. Look at this. Meanwhile, you can write or tell another question. I'm going to click twice over this line, wherever you want, but just click twice. New results. Okay, I'm going to repeat again. This is the optimized result. Okay, click twice wherever you want. Let's see here. Click twice. New results. I like these results, but I like these ones. Electrical results. You can, after this, you can search between the others, but I like these ones. Electrical results. Move here, move it, please, move it. Okay, simulation result. It said about the technology system, etc. But look at this. It says that solar system will produce per year 900 kilowatt hours. 100% of the electricity will be created by solar. Great. Consumption. This is the kilowatt hour per year in consumption from we don't have DC load. We haven't created any protection or any deferrable load that is in some power systems decided. And it says, be careful with this. I like this. I like this one. Unmet electric load. What is it? The system creates 904 kilowatt hour per year. Okay. There is an excess of 160. That is the 17.7% of this. But there's a load, it says 145 kilowatt per year that can be fixed by this system. And this is called the unmet electric load, and is the almost 20% of the system. So be careful with this, because this is telling us that almost 20% of the time, the system can meet the electricity demand. And this is the way the solar system is working and producing electricity every single month. How much of the electricity is from renewable energies? It says 100%. In some other, in some other systems, could be 50%, 60, 70%, because it has diesel. So using diesel, maybe 20, 15, 30%. If you ask me, I prefer everything produced by renewable. Okay, okay, it has a lot of information, and really a huge program with plenty results. We can add, let's say, for example, a kilowatt. Let's say 1, 2. Bergay is a very remarkable brand. I'm going to just for fun. I'm going to include this one. A 6 kilowatt Bergay system. It says, it doesn't say. Yeah, it says 220 voltage AC. So it decides to connect it in the schematic. It decides to connect it to the AC bus bar. Look at it here. And it's asking me about how many are you going to use? Just one? How much it costs? Let's say 1,000 US dollars. Replacements could be only a blade. So let's say it costs, I don't know, 75 US dollars. How much for an operation and maintenance? 50 could be. Okay. Why don't Homer you create some iterations with one of these, two of these, three, four of these. I know what will happen. What will happen is that Homer should tell me, I don't recommend you to use a wind power system. Why? Because right now I haven't I haven't told it that I have a wind resource. It doesn't have any wind resource. So look at here, yeah, at the top side, the right side, the system is not ready to be simulated. So I need to go to the resource when I don't have any resource. So I want to download from internet. Easy and fast. Resources were downloaded successfully. And this is the resources for the place. Remember that at the beginning I put the map and I select the place, so it downloaded from internet, from NASA, that is the American National Aeronautical satellite system, etc. And it gives us this information. It is too short. Why? An average of 2.34 meters, it is in meters per second, can move any wind turbine. They begin, most of them, they begin from 3 meters per second to 20, 25 meters per second. They need this resource. And in this place, we just have 2 meters per second. Anyway, let's put it and calculate. 360 simulations. Okay, results, show me the tables. Wow, surprise. He give us, yes, here, look at here. He says, yes, use wind power. Although it is very few resource, I don't know why he says, let's say, yeah, he says, use it. Use wind turbine. So the optimized solution is solar system, wind power system, battery converter, solar module, just one solar module, 265 watts. Wind turbine, the XL6, battery, just one. The squirrel cage induction generator, no, sorry. The battery, 12 volts, 255 amperes hour, and a converter, 1.2 kilowatts. Net present cost of this system is $4,000. Cost of electricity, 0.583. That could be expensive, but don't remember, for off-grid systems, it's very difficult to compare the cost of electricity with the cost of electricity on grid for a city, for let's say for the cost of electricity in the green university, because the our university, the green university, is connected to the national grid. Off-grid systems is very difficult to compare them because this is a new power generation system, a new energy system. So in that way, cost could be expensive. But imagine that they have finally electricity. They could develop uh, some short projects, small projects, maybe uh, have some entertainment activities during the night or socio-cultural activities. Elderly people making they can meet during the night to talk, to teach or something. Could be very interesting, and they give us a lot of it give us many opportunities to improve the, their wealth. Okay, so far, how do you feel? What other answers are over here? Let's say here I'm going to stop for a while. So far I'm ready if you have any questions or no. I really appreciate this information. Sorry for any mistake or any uh, trouble with my English. For information, our native language is Spanish.
Thank you, Professor Lopez, for
You're
giving
welcome.
us
Thank you.
as a wonderful session. And we have seen that Churupurva has raised his hand. You may ask your question, please.
Thank you, Tohibur, and thank you, Professor Yuri, for your
You're
wonderful
welcome.
presentation on HOMER simulation tool. I have used it. I'm using this simulation tool since 2014. So I'd like to ask some questions that HOMER simulation tool is now very much upgraded, and it's really a wonderful optimization tool with as we got the resources from the NASA. So I have some questions that you have used wind turbine, but isn't it really important that to consider autocorrelation factor or pattern strength and hub height the for getting low COE, that means cost of energy? It's really, isn't it really important to consider?
Sorry. Uh, Repeat, please, the last part.
That's
If it's really important to consider the cost of the wind
yes.
turbine?
I mean, in case of using wind turbine, isn't it
Yes.
really important to consider autocorrelation factor, hub height of the wind turbine? So these parameters, I think we need to consider these parameters, right?
Good, very good question. Yes. How to consider if, yeah, the thing with the wind turbines are, and a very important, the height of the wind turbine, right? That's the issue,
Yeah,
because
yeah. Obviously,
very
it's a
it's
issue.
for different wind turbines we have different wind speeds and different costs. That's a bad thing about HOMER. HOMER can't make that difference. So my recommendation when you use wind turbines, I tell you first, sorry for that, but in paper you calculate the extracted power, that is uh, 1 divided 2 power per power with the basic formula, the basic equation for the power extracted, and compare with the one that Homer give you, because Homer is going to give you the power generated in some of this on some of these graphics or results, and you can compare only for the wind turbine, compare what you calculated
Yeah. Okay.
theoretically with the simulated. Compare that one, and you can see what's the, let's say, the accuracy, and have very interesting and good results with the blogs and the tables and graphic that Homer gives.
Okay, thank you, Professor.
No, thank you.
I have one more
Thank you.
question, that if we use electric vehicle, as well as you know that the electric vehicles nowadays can be used as a load and as well as a spinning reserve to provide electricity during peak hour. If it is not used, if a vehicle owner wants to use that spinning reserve to support the grid in peak hour, so how can he optimize his energy cost? Is there any method to solve to evaluate the cost of energy if he use his spinning reserve in HOMER system, in HOMER simulation tool?
Well, I'm not sure. I haven't worked with those technology. Here, I'm not sure if it has this company is under the controller, the hydro. No, I
I just
haven't
want to add
used.
one thing that for the electric vehicles, you can use HOMER Grid. It has a separate module for the EVs. So you can use HOMER Grid instead of HOMER Pro for electric vehicles. Thank you.
But and the spinning reserve, you have it on the Homer grid? I'm not sure.
Yeah, I just want to ask that if I use my electric vehicle in vehicle to grid mode to use my spinning reserve, I want to provide my spinning reserve energy to the grid. Okay. So how can I sell that energy, reserve energy, and how can I get a better price as a consumer? As a producer. Yeah.
Yeah, will be very no. You have a thesis over here, but very interesting because you know what?
Yeah.
that electricity depends on how you move your car. And if the car in that mode, see if it is just an electric car and E2V electric to vehicle to grid V2G
Yeah.
in V2G mode, and it is electric car, you have to calculate how much to move your car costs. In that way, that price you should place it or put it on the simulation in because Homer or in the simulation, what I would like to know that that simulation or the result give me back the money I paid to load my car. So the cost will be the same. If I load my car, let's say $1 per kilowatt, say something. If I'm going to sell that my energy, could be at the same price, but be careful because regulation, I don't know there, but regulation in Latin America and some countries of Europe, the price of the energy we as a customers, the price of our energy when we sell to the grid is less than
Okay.
than the place we already buy. So you can create. I suggest you to create those two scenarios
Okay.
with those prices.
Okay. Thank you, sir, Professor, for answering my questions. Okay.
Thank you.
Thank you. If anyone else have any question, please raise your hand and you may ask your question. I think there is no more questions. Now we would like to move forward to the next step of this event. It's time for certificate of appreciations. Now I'm going to show it. And please give me a moment for that. Here is it. That's full screen mode. Yeah, here is the certificate for our Honorable Professor Lopez.
Yes, thank you.
I would like
Thank you very
to
much.
thank Professor Lopez once again for giving us such a wonderful event. It was really very helpful for every participant and our faculties and also the students, especially the final year students who are working on the project in renewable energies. And I would like to thank all the participant is here who is being patient with us and they are in whole session with us, and it was really amazing sessions. And we are at the ending of this session today, and we hope we will see in any other session once again. Thank you very much.
Thank you.